IIT पटना में IGS चैप्टर FTS का प्रोग्राम होने वाला है, वर्कशॉप है बहुत बड़ा। तो आपको ले चलते हैं IIT पटना और दिखाते हैं किस तरह से हमने जो है ऑर्गेनाइज़ करवाया है और कैसे स्टूडेंट ही खुद मतलब ऑर्गेनाइज़ करते हैं और इस प्रोग्राम का हिस्सा बनते हैं। हम लोग पहुंच चुके हैं लेक्चर हॉल और यहीं पे ऑर्गेनाइज हो रहा है FTS सेमिनार। चलते हैं सीधा 101 और आपको दिखाते हैं किस तरह का अरेंजमेंट हुआ है। तो प्लान में थोड़ा चेंज था गाइज, हम लोग आ गए हैं डिपार्टमेंट, हमने उठा लिया मोमेंटो और निकल रहे हैं डायरेक्ट लेक्चर हॉल फिर से। चलिए आपको ले चलते हैं लेक्चर हॉल और सीधे दिखाते हैं वहाँ क्या हो रहा है। ये रहा मोमेंटो और लेके निकल रहा है।
With a memento and we extend our sincere appreciation to Mr. Shekar for bringing the valuable industry perspective to this workshop and for his support in bridging the gap between academic and practical of this workshop, and we truly value his contribution. And constant encouragement have been pivotal in strengthening the activities of the IGS Patna Chapter.
Mr. Sumit Shekar, Mr. Divyansh Pandey, participants, students. So it is both an honor and privilege to welcome you all on this workshop FTS-2025. And today we are not only seeing it as a geotechnical perspective, but yes, the agglomeration or the combination of both structural and geotechnical part, which are the most important demand of the current scenario. Today we gather at the intersection of innovation and infrastructure, where theory meets applications and where the future of engineering is being reshaped one simulation at a time. So as this title of this workshop is focused upon, we are very much dedicated through this workshop to give you the hands-on practice which with the help of MIDAS we shall be delivering. So finite-element methods, once confined to the academic curiosity, have now become the indispensable tool in performance-based design. From railway tracks to bridge spans, because we have seen a lot of failures in bridges.
इधर साइड फुल के अरेंजमेंट है IIT का और आपको सीधे अंदर ले चलते हैं और दिखाते हैं अंदर का।
Connection between the industry and academia. Okay. If you see currently the IGS chairman is also from industry, and as our experts told that this is between geotechnical and structural engineering. So the current chairman of Indian Geotechnical Society is heading a company which also works for both structural and geotechnical engineering. IGS Patna Chapter, we have started this chapter in 2019. Previously there was a chapter called Bihar and Jharkhand chapter. From that we came out and we make it a Patna chapter which comprising the people working in this area. And we have started various activities, as you have seen those students were there. Last year we organized one workshop and many more are coming up.
Okay, so very good morning and warm welcome to all dignitaries at the dais, Dr. Bag, Dr. Arpit Jain, convener for this workshop, and very experienced team from MIDAS. We are fortunate to have Sumit and Divyansh, both of them here. And warm welcome to all dear participants. So I am welcoming you on the behalf of department. Unfortunately, our head could not make up today because of some health issues. So first of all, I thank all the participants to come and join. And this is, I think, one of the workshops which we are organizing, keeping in mind that there should be a good collaboration between industry and academia. And we are thankful for MIDAS to take a lead and come forward to also sponsor this one-day workshop, where the students can learn from whatever contribute much, but big thanks to him and his team, so who initiated and did all the various preparations for this one-day workshop. So again, I welcome you on the behalf of the department and thank you for joining. I hope you will have a good one full day interactive session with the MIDAS team and with our faculty members and with some of our students who are participating here. So thank you all and wish you a very happy and good fruitful day. Thank you.
Good morning everyone. I am Divyansh Pandey. I look after the Eastern region for MIDAS.
First of all, I would like to thank IIT Patna, all the dignitaries over here. Thank you so much for giving us this opportunity so that we could present what we have contributed in the designing field and how we can support the student initiative and the academic thing. Recently, MIDAS has been very active in supporting students, in supporting academic workshops, these kind of a thing, because we know that the change that can come will be coming from the student level and then it will be moving forward. Initially, if you have seen, most of the professors and everyone, those who have joined the institution, they have learned this software somewhere or the other in their own education career, and then they have moved on to the education field.
Trucks and all these things, but somehow this bridge was overloaded and there was no maintenance. So all these three issues which has led to the failure of this bridge, and there are many such examples. During the earthquake also we have seen a lot of collapse. So I will just take you to a brief history. So in India, generally we say that any earthquake which is more than 8 magnitude, we call them as a great earthquake. So it happens rarely. You can say maybe once in a 50 year, once in a 100 years. So the major experience all across India. And during this earthquake there were many damages, liquefaction and everything. So liquefaction was first time kind of understood from this earthquake that yes, your soil can also fail. It can behave like a liquid with a zero bearing capacity. So first time in India we noticed the failure of a bridge in this earthquake. Okay, this is a railway bridge. You can see few piers are standing, one or two piers in the between they completely collapsed, and then the rail has also completely packed. Okay, so this was the oldest photo which I can see. I can find out a bridge collapse in India during the high, not very high wind speed, but even in the moderate wind speed, this bridge completely collapsed. You will now see some pictures. Almost you will see like a dancing, right?
Dancing bridge.
So at that time, videography was just newly introduced. So people were very curious. You will find so many videos. There is also one documentary on this bridge, that how this bridge lead to various changes in the design of suspension bridges.
Brave person.
Yeah, another brave person. Now you will see the failure, I think. Yeah. You can see it is almost completely failed. Oh. Right. So what should be the reason for this? Who can guess? Resonance, but because of what? But which load?
Wind load.
So the problem was with this bridge is the aerodynamics. Okay, so you will see this bridge has you can see these solid girders. Okay, heavy solid girders which was used continuously throughout the span. And what happened, because of these solid girders, it did not allow the proper flow of the wind forces. So which lead to the vortex shading and all these things you might have read in your hydraulics, and ultimately it completely collapsed. So this bridge was kind of an eye-opener, and it became mandatory whenever you have a big long span suspension bridge, it is important to do a wind analysis. Always you have to make a small structure, do a wind analysis, wind testing, and this bridge was again later constructed but with the open truss system. Problem with the precast, as you rightly pointed out, what has been seen especially during the Bhuj earthquake. So precast is again a new construction practice. So we do not know much about how they will behave during the earthquake. So what happened in 2001 Bhuj earthquake, one of the school building which was done by L&T. So it was done using the precast slab, precast members. So it performed very poorly. The reason is that they have a good quality control on the precast members, but the connections were not designed for those earthquake or lateral forces. So if you design them, so right now a lot of work is going on. still our Indian standard has not been matured or it has not been developed that much. But there are some standards from PCI, Precast Concrete Institute. So they have good connection practice. And so those bridges are still standing. They are also serving. All railway bridges you will see there is still of a masonry. All old bridges. But what is happening? You are also correct that major bridges we are doing reinforced concrete. But the major failure is also happening in these bridges. Right? Primarily because of the poor design. And whenever you have any tension or any cracks, these bridges will collapse. Okay.
Sir, for curved span, you said that continuity can help. But sir, even then there are segmental collapses, so that will be better in simply supported cases.
See, that is different. So what one can be done? So I am not saying that you make all the span continuous. So the span which are adjusted to the curve one. So you can have, instead of one span simply supported, you can make a 3 continuous spans, right? So the span which is on a curved part, it will be a continuous, and adjacent one will be also continuous, and other can be simply supported. It is not necessary to make all spans continuous, because if you make all spans continuous, then design become more challenging. Nowadays, integrated bridges that we call as continuous, there is no bearing. They are also becoming popular, but you have to then use the advanced software or advanced analysis for that. You have to correctly find out the forces and everything, and then you can also construct and design. Okay.
During the construction, it is possible to follow every provision because in
Code always have some factor of safety. It gives you some chance. Okay, if you do some mistake, a small mistake, the factor of safety can take place, right? But if you are doing the gross mistake, major mistakes, every step you are doing a mistake, the concrete has to be M50, but you are making it M30, so how code will help? Right? Only good engineers can do this, right? Okay, anything else?
That we are going to create is perfectly symmetrical. So left side, the flange width of the flange distance, or the flange width of the left side is equal to the right side. We are going to check on this symmetry button. So when it is checked on, we only see all this, the definition on the left side itself. So in our bridge model, we have these 2 sections, but in between these, we have this tapered section. So
or any rail system. So in these type of projects, soil structure interaction is very important. So soil structure interaction for stations, cross passage, if there is any cross passage there, or if there is any shaft, okay, either it is a ventilation shaft or any other shaft. So that is very important, and in these segments or in these structures, soil structure interaction is a very key thing. Which yes, if you provide damping and all these things, then it will consider. There is one paper also, I will show it to you. Okay, so this is the dynasty analysis. Okay, so when you provide some certain dynasty, let's say let me open that. So this is the model. Okay. Okay, so this is the model. Okay, you are here the dynamic loading is provided. Okay, here the dynamic loading is provided, and we have analyzed the dynamic thing. So we are getting accelerations at different points also because of that movement. Okay, the conclusion part. If you check for the conclusion part, the writer is telling that this is my critical speed, which is this is the speed from where my deformation starts suddenly. Okay, so this is around the 75% of the critical speed, and this is the 30% of the critical speed. Okay, so these are the sleeper deflections, and the type of loading also lead to a sleeper deflection. So this is the different types of loading: heavy loading, standard loading, and the light loading. Yes, sir.
Sir, is there some better meshing possible in some advanced DDS like self-deciding meshing, that where what amount of meshing can be done by the software automatically?
Yeah, in this software do the automatic machine. The only thing you have to do, you have to provide a mesh size.
But here we have to provide mesh size based on our perception, like triangular, rectangular. But is there any possibility that the software take the shape of meshing automatically based on the problem?
Okay, no. So there are two types of meshing.
So now the time for last speech by respected Arpit sir. So here we go. और अर्पित सर ऑन द डेस्क हैं और उनका स्पीच स्टार्ट होने वाला है कुछ समय में.
In India, outside India. So the topic which I am focusing upon is majorly the soft soil, and what are the practical applications which we can further use for the enhancement. Okay, so let's start like that. It would be moved like introduction, then what are the problems associated, what are the reinforcement technique and what is soil enforcement, and suitable ground improvement technique, and some case studies that finally differences. So yeah, we can see this image here. So it is like they have just contractor had just poured the material and they just went away. But here we can see how this all amount washed away. Even there was some vegetation, even then it completely went outside. So if we are aiming for Gati Shakti, we are aiming for bullet train. So before bullet train, we have to see these things. Otherwise, if bullet train is running, I think bullet train will carry all these tracks with them. Is it? So what to do and what not to do, we will see. These are some of the images of accidents in past which most of us have seen in the images and at many places. So if we want to increase the speed of trains, currently what is the speed of Vande Bharat? Anyone know? Recent study of 2024, which is a practical application rather than just the lab-based experiment. So it was successfully utilized, and these elements were called as geospikes. They have made some patent out of it, and which was very successfully used. But in India, there is no such kind of work has been done on this case. So
तो इस तरह से करते हैं आज का ब्लॉग एंड, और सभी लोग बाय कर दिया. शिवांग भैया, थैंक्स फॉर वाचिंग. तो हमारे कैमरामैन साहब हैं स्क्रीन पे कैमरा लिए हुए. तो कैसा रहा आज का प्रोग्राम, क्या बताना चाहेंगे?
बहुत अच्छा रहा
प्रोग्राम, बहुत बढ़िया रहा. शिवांग भैया कुछ कहना चाहेंगे?
बहुत बढ़िया रहा,
मज़ा आ गया.
अच्छा रहा.